Check this.
Okay, welcome back. Today we're going to talk about the quadratic formula and graphing parabolas, sort of a two-in-one lesson. So let's get started. We're going to start off by trying to solve an equation here. And so there's reverse FOIL right there. You have to write your parentheses. You have to write your equals 0. And you put down your x's, right? Because you can only do reverse FOIL if there's nothing here, a 1 meaning invisible 1. And now you look for two numbers, two factors of 30 that add to give you -5. So what are two factors of -30? Do any of these add or subtract to give you a 5? Specifically a -5. And 1 and 30 cannot add or subtract to give you a 5. 2 and 15 will not do it. 10 and 3, that'll be either 13 or 7. That won't do it. 6 and 5 is either going to be 11 if you add or 1 if you subtract. So none of these work, which means this is not factorable. And what does that mean? Does that mean there's no answer? No, it doesn't mean that there's no answer. It just means that you can't factor this equation. So how do we find the answer for equations or expressions that are not factorable? Okay, what we're going to have to do is have some other strategy, and that strategy is called the quadratic formula. So how do you use the quadratic formula? Well, first off, you have to understand that your quadratic formula has to be written in what's called standard form equal to 0. Standard form is ax squared plus bx plus c. That's the standard form of a quadratic expression or equation. And you need, just like for factoring, you need to have a 0 on the right side. 0 is the hero once again. So just to be clear, for factoring and for quadratic formula, you absolutely need a 0 here. If you try to do the quadratic formula without a 0 on this side, it will be wrong, and you won't know it's wrong until you're done, until you check your answer. Okay, so let's try an example here. Solve this equation here using the quadratic formula, which is right here. So you have to make sure that it's in the right format. Is this in the form ax squared plus bx plus c, and is there an equal 0 here? Yeah, everything is perfect. You can see that a is 1 because there's nothing here. That means there's an invisible 1 here. B is -1 because there's no number, but there's a negative. So b equals -1. And c equals -6. You take that a, that b, that c, and you plug them into, or substitute them into the a, b, and c here. So the first step is what I call substitute, where you plug in these numbers into the formula here. And the best way to do that is to leave empty parentheses wherever you see one of these letters. So negative b, I'm going to leave parentheses for that. Trust me, the parentheses will keep you from making sign mistakes, so you want to use a parentheses. Plus or minus the square root of, once again, parentheses where the b goes, b squared minus 4 times a times c all over 2a. So you see what I've done here is I've written the quadratic formula, but I've removed all the letters and replaced them with an empty set of parentheses. This is the best way to do this. Otherwise, double negatives and things like that will mess you up, all right? So now, what did we say a was? A is 1. So we'll plug in a 1 for a, which is on the bottom here. There's also an a here, right? What's b? B is -1. There's a b here, and there's a b here. And what's c? The only c is the one over here, and it's -6. So this is what I call substitute. Next is simplify. Take this huge mess here and clean it up. You have -1. When you multiply the two negatives, you get a positive, so this becomes +1, plus or minus the square root of -1 squared. Well, without the parentheses, this -1 squared is actually -1, but as soon as you put parentheses around it, you're squaring the negative as well, which makes it +1. So if you ever square something in a negative number in a calculator and you get a negative answer, it's because you didn't use parentheses. So 1. Now you have -4 times 1 times -6. The two negatives here will cancel out, giving you a plus, and 4 times 6 is 24. And on the bottom, you have 2 times 1. Are we done simplifying? No. Let's keep simplifying. So what else can we simplify? Well, 1 plus 24 is 25. So this becomes 1 plus or minus the square root of 25 over 2. And the square root of 25 in most countries is 5. So 1 plus or minus 5 over 2. And that's simplify. We can't simplify any further than that. The last step is split, okay? Because 1 plus and minus, the plus and minus are two different answers, 1 plus 5 and 1 minus 5. So we're going to split this into two answers here. So the last step is called split, and you're going to write your answer twice here. X equals 1 plus 5 over 2, and the other x is going to be 1 minus 5 over 2. And what are your two answers now? Well, 1 plus 5 is 6, divided by 2 is 3, and 1 minus 5 is negative 4 over 2, which is going to be negative 2. So my two answers are x equals 3 and x equals negative 2, and there you go. A different take on the quadratic formula from Algebra 1, but trust me, substitute, simplify, split keeps you organized. And definitely use your parentheses when you plug in. Okay, so now let's do the problem from the warm-up that we couldn't do a few minutes ago. All right, we tried to do this by factoring. It was not factorable. When something isn't factorable, it means the answers are going to be what are called irrational numbers. They're going to be like square root of, a number that cannot be square rooted without getting decimals, that sort of thing. So here's what we do. Once again, check to see if you're in the right form. Ax squared plus bx plus c equal to 0. Yes, everything is good here. A is, identify your a, b, and c. A is 1, b is negative 5, and c is negative 30. Now, if your equation is not in the correct form, you can rearrange it and do what you need to do to make it. You can make sure that there's a 0 here. You can make sure these are in the right order. Now, we have our a, b, and c. Now, the first step, substitute. You see I've written the entire formula here, left out the a's, b's, and c's, and put parentheses where they used to be. Now, this is a b, so it's going to be a negative 5. This is also a b, it's also another negative 5. This is an a, it's going to be a 1. This is a c, it's a negative 30. And this is also an a, so it's a 1. And that's the substitute step. Now simplify. With simplify, we just clean this up here. Negative 5 is positive 5, plus or minus the square root of, this is negative 5 squared, so it's positive 25. Once again, you need the parentheses around this if you expect to get the right answer from your calculator. Negative 4 times 1 times negative 30. Well, the two negatives are going to cancel out, so this becomes a plus, and 4 times 30 is 120. The bottom is 2 times 1. So, are we done simplifying? No. So keep going. This is going to be 145, so this is the square root of 145 here, over 2. Now, you might be tempted to go and change this into a decimal with your calculator. The square root of 145 is not a whole number, and that's the reason why the original problem wasn't factorable. So here's the thing. I don't want you to do that. I want you to leave this as what it is, meaning leave this. So you can't simplify any further because you're not going to change this into a decimal. If this was a perfect square, meaning you can square root this and get a whole number, then go ahead and square root it. Like if it was 169, then that would be the square of 13. But since it's going to be a decimal, don't change it to a decimal. We don't like decimals in Algebra 2. So last part, that was simplify, by the way. Last part is to split. And the way you split is you take the plus and you take the minus and you separate them into two different answers. So one answer is going to be 5 plus the square root of 145 over 2. And the other answer will be 5 minus the square root of 145 over 2. And there are your two answers. Now, in the textbook, when you go to look at the answers, they give you answers in decimal. So can you change these to decimal so you can check your answer? Yeah, you can. Like for instance, this right here, 5 plus the square root of 145. Well, 5 plus the square root of 145 equals, and then divide that by 2. So that would be 8.520797289. That goes on forever. It never repeats. So yeah, what's the textbook going to do? They're probably just going to round it off to the nearest two decimal places, which is not the same as having an exact answer. This is an exact answer. This is what's called a decimal approximation because you've rounded the hell out of it. Okay? So anyway, the point is we don't like to do this in math or engineering or science because, you don't want to build a bridge with too many round off errors, right? Okay, so how about over here? 5, it's the same thing but with a minus. Oops, that's supposed to be all the way across there. So it's 5 minus, so I'm just going to go back to what I wrote before and change it to a minus instead of a plus, minus, and then divide that by 2. And I get negative 3.5207, blah, 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 blah. All right, we'll round it off to there. So if you look in the textbook, if they do give a decimal answer, it'll be these two answers. So if you're checking your work and you're checking it against an answer that's in decimal, yeah, go ahead and change it to decimal. But as far as I'm concerned, what I want for my quizzes and homework, I want this, okay? And later on in chapter 7, we'll learn how to take these and simplify these radicals a lot more. But right now, you can just leave them as this. Now, how do you know whether or not you should do the square root? You should do the square root if it's a whole number. So basically, take the square root of 145 on your calculator. If it comes out to be a decimal, then don't take the square root, right? However, if you took the square root, let's say we said 169 before, If it was the square root of 169, for instance, you get 13. Oh, that's fine. Or 196, you get 14, 225, you get 15, that sort of thing. So if you're not sure, just take the square root with the calculator. If it's a whole number, then use it. If it's not, don't use it, okay? If it's a whole number, you'll have an answer that's rational, meaning it won't be a square root. It'll be like this problem up here. Okay, now let's move on to something called the discriminant. Basically, the discriminant is the part of the quadratic formula that's sitting underneath the square root, this part right here. So this is the discriminant right here, all right? And what we do with this is actually really useful. If you know the value of this quantity right here, it'll tell you if the problem that you're trying to solve was factorable or not. It'll tell you if you're going to get one answer or two answers or no answers. It'll tell you whether the answers will be rational, meaning decimals that stop or whole numbers, or if it's irrational, meaning those crazy decimals that go on forever and never repeat, like pi. All that can be figured out just by looking at the b squared minus 4ac. So you have here a little table. If you figure out what this is, if you calculate the b squared minus 4ac and it turns out to be 0, you're going to get one rational answer. And the equation is factorable. So you could have skipped the quadratic formula and you could have factored. If you get a perfect square, which by the way, 0 is a perfect square, you're going to get two, that's not 0, so a non-zero perfect square. You're going to get two answers. And it was factorable, so you should have just done it by factoring and save yourself a lot of work, because this is a lot more work than factoring. If it's not a perfect square, but it's still positive, right? Meaning like a number like 17 is not a perfect square. Then you're going to get two answers, but they're going to be irrational answers, the kind of answers that are decimals that go on forever and never repeat. And I don't want you to write them as decimals. I want you to write them as just the square roots that they are. So the equation is not factorable. And finally, if you get a negative number, you're going to get no real answers. You're going to get two what are called imaginary or complex answers, and we're going to talk about imaginary answers later on in this chapter. Okay, so let's use the discriminant. Let's use this b squared minus 4ac to check out a few equations here and see what would happen before we solve them. Okay, so here we go. Describe the number and type of solutions of this equation and then solve the equation. So we're going to use just the discriminant. So once again, here's the quadratic formula, just so we can have it next to us so we can see it. And what we want to do is we want to find just the b squared minus 4ac part, just this part here. This is called the discriminant. The word discriminant comes from the word discriminate, right? Is related to the word discriminate. And the word discriminate means basically to separate things into groups, right? Obviously, there's a negative connotation there if you're talking about just separating people into groups. But for numbers, you're separating things into these groups here: rational, irrational, complex, that sort of thing. So we're going to take this equation and figure out what group it fits into, right? So what's your a, b, and c? This is ax squared plus bx plus c equals 0. If the equation that you're solving is not in this form, you'll have to put it in this form before you decide what a, b, and c are. But now that we do know what a, b, and c are, we can take a, which is 1, b, which is 22, and c, which is 121, and plug them into b squared minus 4ac and see what we get. So b squared is 22 squared. Use parentheses again. 4 times a times c. Well, a is 1 and c is 121. And you might want to grab a calculator now. So I think this is 484 minus, and this is going to be 484. So what I'm getting here is 484 minus 484, that's 0. My discriminant is 0. And according to this table over here, if you get a 0, you should only get one rational answer, and this was a factorable problem. So that means you can actually like stop here and go, you know what, I should just factor this. I can solve this by factoring. And the fact is you can. Like if you want to, you might realize, hey, this is actually reverse foilable. X and X, two numbers that multiply to give me 121 and add to give me 22 would be 11, and put a positive. They're both positive. So when you solve with the zero product rule, you get x equals negative 11 twice. So just that's your answer, x equals negative 11. That's how fast you can solve this if you know it's factorable. And the fact that this is a 0 tells you it is factorable. So you can skip the quadratic formula if you know something's factorable. If you're not sure, check the discriminant. Check the b squared minus 4ac. If you see an equation that you were about to solve, okay, and you go, I don't know if this is factorable or not, check the b squared minus 4ac. If it works out that it's factorable, then factor it. If it's not factorable, then use the quadratic formula. That's pretty much what we do with this. Now, we solved it. we could have also, if just to prove to you that this works both ways, we could have also used the quadratic formula here. So negative b, this is the substitute step, is negative 22, plus or minus the square root of b squared minus 4ac, we already know is 0 because we already did it, over 2 times a, which is 2 times 1. So what we get is negative 22 plus or minus 0, the square root of 0 is 0, over 2. Well, plus 0 and minus 0 is the same thing, so this is just negative 22 over 2, and the answer is negative 11. So substitute, simplify, there's no need to split because it's plus and minus 0, and you get your answer. And you can see the answer is the same in both cases. So using the discriminant, this b squared minus 4ac, will save you a lot of work if you use it first. Okay, in example 1, we solved this and we got 2 answers, 2 rational answers, not crazy decimals. So what should the discriminant be? Well, the discriminant should be a perfect square. See, if you get a perfect square like 25 or 16 or 36, a number that you can square root and get a whole number, then you're going to get 2 rational answers and the equation is factorable. Now we did use the quadratic formula up here because that was what I told you to do. However, let's say you're doing a quiz or a homework and you get to choose what you do. So notice I didn't say you had to use the quadratic formula here. Just find the discriminant. So a equals 1, b equals negative 1, and c equals 6 because of a, b, and c, right? What's b squared minus 4ac, the discriminant? It's negative 1 squared minus 4 times 1, which is a, and negative 6, which is c. Well, negative 1 squared is positive 1. The 2 negatives here cancel out, giving you 4 plus 6, which is 4 times 6, which is 24. And your discriminant is 25. This is not only positive, it's a perfect square. What does that tell you that it's a perfect square? We'll go back to that table. If you get a perfect square, you're going to have 2 answers that are both rational, meaning not crazy decimals. They could be fractions, but they're not going to be those, crazy square root looking things. And the equation is factorable. So once you know the equation is factorable, you don't have to use the quadratic formula. You can say, you know what, this is factorable. Let me just go ahead and do reverse FOIL and get my answers that way. So x and x, 2 numbers that multiply to give me negative 6 but add to give me negative 1, 3 and 2 will give me 6. And if the 3 is negative and the 2 is positive, they'll multiply to give me negative 6 and they'll add to give me negative 1. That means x, when you set these equal to 0 with the 0 product rule, x is 3 and x is negative 2 are your 2 answers. And if you see that was nice and quick compared to when we did it with the quadratic formula up here. Okay, where was it? Here it is. All this work to get x equals 3 and x equals negative 2. But since we know that this was factorable because of the discriminant, we save time. And there it is. All right, one more of these and then we're going to go on to the next section. Describe the number and type of x-intercepts of this parabola. Well, we learned that if you want to find the x-intercepts of a parabola, you make the y 0. So making the y 0 gives you this equation. X squared minus 5x plus 10 equals 0. And now you see this is just your plain old solving situation here. Okay, now it looks like it might be factorable, okay, but let's check the discriminant first. Even though it looks really simple, like, hey, I should just try to go right to factoring. Let's not do that. Let's check the discriminant. So a is 1, b is negative 5, and c is positive 10. What's my b squared minus 4ac? Well, it's negative 5 squared, that's the b squared, minus 4 times 1, which is a, times 10, which is c. Negative 5 squared is positive 25. There's only one negative here, so this does not become a plus, it stays a minus. 4 times 1 is 4, times 10 is 40. 25 minus 40 is negative 16. I got a negative number, all right? If you get a negative discriminant, what does that mean? Well, let's take a look at the table. If you get a negative number, that means there are no real answers. There's no real solutions. Okay, and later on in the year, we're going to learn about what's called an imaginary solution or a complex solution. But right now, for all intents and purposes for us right now, is that there's no solution and the equation is not factorable. So why is it good to have checked this? Well, if there's no solution, you can stop. You can just say, oop, negative discriminant, no real solution. You might have heard of the term all real numbers. There's no real solution. There is an imaginary solution, but we haven't gotten up to that. We're going to do that in the next lesson. But for now, there's no solution. All right, you can stop. You don't have to factor or use the quadratic formula because neither one of those are going to work. Okay, this next section is graphing quadratic functions using the axis of symmetry. A quadratic function, when you graph it, looks like a parabola, or is a parabola. And a parabola is a symmetrical thing. So it has like a middle point called the vertex. And that vertex is either the lowest point on the parabola, or if it's an upside down parabola like this, it could be the highest point. So it's either the minimum value or the maximum value of the parabola at the vertex. And because it's a symmetrical shape, if you fold it in half, you can fold it in half on this dotted line here, and it'll fold onto itself. It's symmetrical. So that line where you fold it is called the axis of symmetry. And we can figure out where the axis of symmetry is, and that will help us make a table to graph it. And that's what we're going to do in this lesson here. So here's the strategy. You're going to use this little formula here, x equals negative, and then b over 2a, this thing right here. We're going to use this little formula here to find the axis of symmetry. And once we know what the axis of symmetry is, we're going to make a table. We're going to go like 2, maybe 3 points to the right, 2, maybe 3 points to the left from that axis of symmetry, and that'll be how we find the table, okay? So here we go. Here's the function, y equals 3x squared minus 12x minus 9. Identify the axis of symmetry. Let's do that first. So the formula for the axis of symmetry is x equals negative, and then you have b over 2a. Well, once again, this is ax squared plus bx plus c. Okay, the same standard form that we talked about before. So my a is 3 and my b is negative 12. So when we come over here, it's x equals, there's a negative, which is separate from any other negative that you're going to have. B is negative 12, so b has its own negative, it's up here, over 2 times a, just like with the quadratic formula at the bottom is 2a, right? And your a is 3. So what is this? Well, negative and negative, these negatives cancel out. So now we just have 12 over 6, and 12 over 6 is 2. My axis of symmetry, AOS, is a vertical line, x equals 2. So you're going to come over to your graph, x equals 1, x equals 2 is right here. You're going to draw that on your graph as a dotted line. Axis of symmetry, like it was in that picture I showed you a minute ago, is a dotted line. Okay, I'm using red so that it stands out like that. This is your axis of symmetry. And the equation of that line is x equals positive 2. Make a table of values and plot the function. Well, when you go to make a table of values, you need to know where the center of the parabola is, otherwise you don't know where to make the table. Like you really shouldn't start with 0, 1, 2, 3, 4, 5 all the time, because what if the parabola's over here? Then 0, 1, 2, 3, 4, 5 is all over here, it doesn't work. So what you do is you look at your axis of symmetry, okay? You say, all right, this parabola is centered at 2. It's going to be in the middle, its middle rather is 2. Okay, you don't know where it is, it might even be upside down for instance. But the point is the center, the vertex, will be on x equals 2. So put the 2 in the middle of your table. Now you should go 2 to the right and 2 to the left. So 2 more to the right would be 3 and 4. And 2 more to the left would be 1 and 0. So ironically it is 0, 1, 2, 3, 4, but that's not because I just started at 0 randomly. It's because this is the center. That's the axis of symmetry right there. And now you can make a table. You can plug these numbers into the function here and see what you get. I'll do that off camera so that you don't have to watch me do it. Okay, so I've plugged in 0, 1, 2, 3, 4 into this equation here, and these are the numbers I got. And now you can use these to plot your points. So I'll do that now. So there are my points. 2 of them go off the graph, that's okay. And then you connect the dots with a nice smooth curve. Okay, the bottom should not be pointy, it should be round, like kind of like a smiley face. And there you go, there's your parabola. That's your graph. Now, it says identify, the next part is identify the vertex, that center point. Well, here it is. What's the coordinates of the vertex? It looks like the vertex here is 2, negative 3. And it's actually this point right here. This is the vertex right here, the center point of the parabola. Identify the maximum or minimum value. Well, since this parabola has a lowest value, it has a minimum. Okay, it has no maximum because it goes up and up forever and ever. But it does have a bottom, not a top. So the bottom happens at y equals, what is this? Y equals -3. So it has a minimum value of y equals -3. Okay, and that's just basically the same number as that right there, because that's where the vertex is. State the domain and range of the function. The domain of any parabola is going to be all real numbers. So you can kind of save time with that. Domain is where the x's go, and the x's go forever and ever in both directions, so all real numbers. That's the symbol for all real numbers. What's the range? The range is what the y's are doing, and you can see the y's start at -3 and go up. It doesn't go below -3, so the range is y is greater than and equal to greater than or equal to -3. So the idea here is simple. Use this little formula, x equals -b/2a, to find the center of your table. It is the axis of symmetry. And then from there, you can do everything else. Okay, let's do one more and call it a day. Identify the equation of the axis of symmetry. So once again, it's x equals -b/2a, which in this case, b is, oh, forgot the negative, and then your b is 8 over 2 times a, which is 2 times -2. Okay, simplify that. Well, there's 2 negatives in here. They're going to cancel out, and this becomes 8 over 4, which is 2. So once again, my axis of symmetry is x equals 2. Not too creative with the question there. Same exact axis of symmetry. But yeah, no problem. There it is, x equals 2, same thing as last time. We'll draw it as a dotted line. Then you make your table, put the 2 at the center of your table, and go a couple to the right and a couple to the left. So we'll go 3, 4, and 1, 0, just like last time apparently. All right, and now we plug all those numbers into the function and fill in the table. I'll do that off camera yet again. Okay, so I filled in my table here, and now I get to plot my points. So 0, -6, that would be 1, 2, 3, 4, 5, -6 down here. 1, 0 is here. 2, 2 is here. 3, 0 is here, and 4, -6 is here. And you can see there's my parabola. All right, and I've drawn my parabola, try to make it as nice and parabolic shape, not pointy. All right, so we've done that part here. Identify the vertex. What is the vertex of this parabola? The vertex is going to be that center point. Okay, it's right there. And it's 2, 2. Does this have a minimum or maximum value? And what is that minimum or maximum value? Well, you can see this parabola has a top, but no bottom, right? The arrows mean it goes down, down, down forever. However, it does have a top, so it has a maximum value, not a minimum value. Okay, maximum of y equals something. Well, what's the y value here? It's y equals 2. Now, what's the domain? What are the x's doing? Well, the x's go in both directions. They go forever to the right and forever to the left. So the domain is all real numbers. And what's the range? The range is what the y's are doing. Well, the y's, meaning the vertical part of this parabola, it goes from -2 down forever, but it never goes above 2. So you say the range is y is less than or equal to 2. It never goes below +2 here. And that's it. We're done. See you at the next video. Check this.